So let's generalize here. We know that in the previous one, our denominator was a 5 because we were breaking it up into fifths. What's the denominator of this new fraction going to be? We're breaking it up into bths, whatever b is supposed to be, so we're going to be dividing this thing by b. So it'll look sort of like this. So far, stuff divided by b. And then as far as that stuff goes, we have a weighted average up top, just like we had before, some number that's going to be multiplied times x1 plus some other number that's going to be multiplied times x2. And we're going to have to figure out what these weights are. Well, the easy one is the weight of A, which I just scribbled out for some reason. It's the weight of A. Remember, that goes on the x2, just like it did right here, the 3/5, just like it did up here, the 7/8 for the 7/8 point. So that means that the A2 is going to get the weight of A. Lol A. It's the top number of your fraction, A. Now we just have to figure out what the other weight is. So remember that in exercise 3 here, we got 2 from just subtracting the bottom from the top of the fraction that we were given, 5 minus 3. We just do the exact same thing here. We're going to do b minus a. Think of it like this. If I wanted to find this distance here from p to b, if the whole thing is b, and I've already used up a, then the part that's left over is the difference between those. It's just basically using the segment addition postulate backwards. So this is a b minus a. That's the weight that we're going to put on x1. In parentheses, b minus a. Boop. And then your y-coordinate is going to be identical to that with y's in the place of x's. So here you go, for your notes. Partitioning formula. If point A at x sub 1, y sub 1, and point B at x sub 2, y sub 2 are points in a coordinate plane, then in a coordinate plane, that's weird, then the point P on your segment AB, that is the fractional distance A over B from point A to point B, has these coordinates, and it's the formula that we just came up with. We have an ordered pair. When we're all done with this formula, of course, we should have coordinates in the coordinate plane, an ordered pair. Here's the x coordinate that we just came up with. It is the bottom of the fraction minus the top of the fraction times x1 plus the top of the fraction times x2, all of this divided by b. And then you do the exact same thing with your y-coordinates. Now remember, it's super important to realize that this is a weighted average. And so x1 and x2, they're not interchangeable. Just like if you exchange the grades that you make on quizzes and tests, you now have a different average for most people than the average that you currently have. So let's put this formula into practice. You may have to pause the video right here so that you have enough time to write down your formula. Just a heads up though, you do not have to have this formula memorized. It's not on a memory card. Instead, you just have to know how to use it once it's written down. And on the quiz, you can use your notes, and on the test, I'll have it printed for you. So let's look at exercise 3. Show that the midpoint formula is a special case of the more general partitioning formula. So the partitioning formula is supposed to work for any fraction, a over b. If we're talking about a midpoint, our a over b is the fraction 1/2. So let's apply the formula to 1/2. All right, here we go. So since I'm taking half, I know I'm supposed to divide by 2. I'm going to make an ordered pair here with 2 little fractions, like so. And then my weights go like this. I need something times x1 plus something times x2. Do the same thing with the y's. And the top number up here goes with the x2 and the y2. So those are the numbers 1, boop, and boop. What about y1 and x1? Well, they get the piece that's left over. And the piece that's left over is just the bottom number minus the top number. So 2 minus 1 gives us 1. It's the weight that's going to go on these other ones, x1 and y1. Does this formula look familiar? It should. It's just the same thing as the midpoint formula. We just usually don't write the ones here. So what I'm saying here is that this partitioning formula is super powerful because it contains every single fraction that you care to use, including the midpoint formula as well. All right, so in the next exercise, on exercise 4, We're given two endpoints, A and B. Remember, we can't mix up which one is which. We want to find the coordinates of the points that's going to divide segment AB into fifths. So your fraction, A over B, is going to be, say, 1/5, 2/5, 3/5, 4/5. See if you can do this on your own and then come back to the next video here if you get stuck or just to check your work.